Hello everyone, and welcome to the Lambda Expression Overview or Review lecture. In this lecture, we're going to give a brief background and review of Lambda Expressions with Python. Since we're going to be using Lambda Expressions so often with Spark and RDDs with Python, it's important to review them. If you already feel pretty comfortable with Lambda Expressions, you can go ahead and feel free to skip this lecture. But I'm going to go ahead and give them one quick review by jumping to a Jupyter Notebook. Let's go ahead and get started. Alright, so here I am at a Jupyter Notebook. Now we've seen Lambda Expressions used when we're working with the apply statement in pandas in Python, but we're going to be using them a lot with Spark and RDD. So let's go ahead and break down a Lambda expression. Remember that a Lambda expression allows us to create anonymous functions, which basically means that we can quickly make ad hoc functions without needing to properly define a function using def. So to review how to create a normal function, you would say something like def. We'll say square, num, and then we'll go ahead and say result is equal to num to the power of 2, and then return result. Then if I call square on some number, such as 4, it returns the square of that number, which is 16. Let's go ahead and break this down. So one thing I don't have to do is redefine result here. So I can just say def square of num, and then just return num squared. And that'll work the exact same way. So now if I call square of 4, I still get 16. And we can actually write this in one line. So I can continue to put this in one line. It's bad style to do this, but Python does allow for it, and this will still work. So let's check that out. If I run this cell again, so now it's in 5, run this cell again, you get the same result. And now what we can do is take this syntax and turn this into a Lambda expression. So turning this into a Lambda expression would look like this. We say Lambda, we skip def, and you skip naming the function, but you do keep whatever variable name you want. So then we say Lambda num, colon, and then you skip typing in return, and you type whatever transformation you want to return. So then we'll say num to the power of 2. And that's a Lambda expression. So if you wanted to get this back, you could say assign this, although you usually wouldn't assign a Lambda expression because that kind of defeats the purpose of Lambda expression, but this still works. So SQ of 5 is 25. So what we're going to go ahead and do is a couple more Lambda expressions using some strings and numbers just to get an idea of how we can use them. So if we wanted to check if a number was even, we could say something like Lambda num, and then say num mod 2 is equal to 0. And I'm going to call that even. So we'll say even of 3 is false, even of 4 is true. And just to reiterate, you usually wouldn't assign a Lambda expression, you would use it as part of a method. And we'll see that later on when we deal with Spark and Lambda expressions. But let me go ahead and show you just a few more examples to really drive this home. We can go ahead and say, let's say we wanted to grab the first character of a string. We'll say lambda, take an s, return s index 0. So then saying first of some string, it returns a. Then if we wanted to reverse a string, we could say, for instance, rev is equal to lambda s, and then return s. And you can actually use kind of an indexing trick here that will print everything back in reverse. So we can say a, b, c, d, e, and it returns back e, d, c, b, a. Okay, one last example. Just like a normal function, you can actually accept more than one function into a Lambda expression. So to show you what I mean by that, I can say def adder x comma y, return x plus y, which means I can say adder 2 and 3, it returns 5. Just like I broke down the last function, we can break this down into a Lambda expression as well. So to put the logic out, I can put this all in one line, get rid of return. I don't need these parentheses. Get rid of the name and of def, and just replace this with lambda. And that's a Lambda expression as well. So if I reassign this to be adder lamb, and I call adder lamb on 2 and 3, it works the exact same way. So let's show that one more time. 3 and 3, that's 6. Okay, So lambda expressions really shine when used in conjunction with some sort of map, filter, or reduce method. And those methods are transformations with Spark RDDs. So let's go ahead and end this lecture here. Feel free to post any questions about lambda expressions to the Q&A forums, but everything we reviewed here is really all you need to know as we move forward. Thanks everyone, and I'll see you at the next lecture.